let's solve a few more quadratic equations by the quadratic formula. So again, I'll speed it up a little bit in this video from the last one. We'll always start by applying the formula. And I always recommend, this is a formula that you should memorize. If you don't have it memorized, I think just by practice and repetition, it makes it easier to remember what's going on. But hopefully, as we examine the proof of this in class, it made a little bit more sense as to why those components are what they are. But ultimately, I would just suggest practicing, of course, on an online exam. If you're given a note page where you can have a sheet of notes, this is obviously something I'd write down on your note card to use. But in general, in most math classes, it would be assumed that you have this formula memorized. It's a very fundamental formula for a lot of reasons. Anyways, it's always negative b. In this case, b is 1. Negative 1 plus or minus b squared is also 1. Minus 4ac. 4 times 3 is 12. 12 times 10 is 120. And that's a double negative, so plus 120. All divided by b times 2a. Sorry. 2a is 2 times 3 is 6. And here, the discriminant again is going to be 121. That's another perfect square. So whenever we get a nice perfect square, it means that our answers will be rational. So here I'm going to get negative 1 plus or minus square root of 121 is 11 over 6. And it will result in fractional answers, but that's okay. So I'll either have, negative 1 plus 11 would be negative 10 over 6, which would reduce by 2 down to negative 5/3. And then if I do the negative variant, that would be negative 1 minus 11. Negative 12 over 6 is negative 2. And I get one fraction, one whole answer, which are, again, whenever we get rational answers, it means that this could have been factored. And you could have used a magic X or whatever other method to just factor this instead. But it is worth noting that you're always going to get the correct answer, obviously, because that's the whole point of the formula. Anyways, let's do another one. And I think it's helpful to notice that the discriminant always controls and tells us whether or not something will be factorable using whole numbers, using rational factors. And so if you ever wanted to know, is this polynomial prime or not, you could always check via the discriminant. And that's kind of like a shortcut. And you could still use regular factoring if you prefer to the quadratic formula. But in my mind, I just like the quadratic formula because it always works, and I've gotten the hang of how to do it pretty quickly. And again, that just comes with some practice. So looking at the next one, negative b here is going to be 8 plus or minus b squared is 64 minus 4ac. 4 times 15 should be 60. So minus 4. And then 60 times 2 would be minus 120. All over 2a is 4. And here, it looks like we're going to have a negative discriminant. Let me just double check that because I did it in my head and for some reason I confused myself momentarily. Negative 4 times 2 times 15. Yeah, it's negative 120. And again, noticing that I have 64 minus 120. Of course, that will be negative. So again, this would be another example where I'm going to get an imaginary answer due to a negative discriminant. And I could check, what is that? And see if it is a perfect square or not. Negative 56 is not. So we would have x is equal to 8 plus or minus. And again, since it's a square root of a negative, I could rewrite that as I times the square root of 56 over 4. So I could just sort of, I take this, which is negative 56, pull out the negative as I, leaving 56. And of course, if we're trying to simplify and clean up our answer and kind of write it as I did up here, we could always think about how well does this radical simplify. So, if we're going to progress, we want to simplify the radical if possible. Here we couldn't because it was 11. But here 56 is 9 times 8, I believe. No, 9 times 6. Yeah, sorry, 9 times 6. It's 54. No, 56 is not 9 times something at all. But, it comes with factoring 56. I probably should have looked at this one before we did the video. I believe, and if you're not sure how to factor the root, instead of guessing, which is what I'm kind of doing right now, I was getting my times table mixed up a little bit. We could always just factor it. Actually, 56 is 4 times something, right? Because 60 is 4 times 15, so this would be 4 times 14. And that would be 7 times 2. So actually there's no 9 in there at all, of course. Now that I think about it, it's really dumb. I think 9 is in there. But there is a 4 in there, and 4 is a perfect square. So I could rewrite root 56 as square root of 4 times 14, and that would be equal to 2 rad 14 by simplifying. So kind of this is what I would do in my head. Or you could always do it on scratch paper off to the side if you're trying to figure out, okay, how would this simplify? Or even, some calculators could simplify it for you. But at the end of the day, this would be equal to 8 plus or minus 2i root 14 over 4. And of course, I think it's nice to actually write it by separating it into 2 parts. Because, of course, I have 8 over 4, which is just 2. And then I have 2i root 14 over 4, and 2 over 4 will reduce to just 1/2. So I could rewrite this as root 14 over 2i. And that's about as simple as I can express the 2 answers to that equation. Looking at the last 2 examples, as a reminder, you always need to make sure your equation is set to 0 before progressing. And I believe a couple of these examples we actually did in past videos we solved these same equations by factoring. I can't remember which ones exactly, but you can go back and check your answers that way. But it could be very easy to just apply the quadratic formula right away here, because it kind of looks like x squared x constant, but since it's not equal to 0, the quadratic formula won't work in that case. So I need to make sure to subtract that 10 first to properly set it to 0. Now I can use the quadratic formula. So getting those answers, I would have negative b plus or minus b squared minus 4ac. In this case, I'm going to have negative 4 times a is 6 times negative 10 is c. And that would be plus 240. And that's all going to be over 2a, which is 12. And I could check what is 240 plus 121. That is 361. And again, if I wanted to know, is this a perfect square or not, I could double check by square root. But that is indeed 19 squared. So this would all amount to be negative 11 plus or minus 19 over 12. And again, the discriminant here is a perfect square, so we're going to get rational answers. Whereas over here, it was not a perfect square. We're going to get irrational answers. And when it's negative, we're going to get imaginary answers. So a type of question you could have in your homework is classify the answer. What type of answer is it? And that's just kind of coming down to understanding, well, what are those types of numbers? What is the difference between a rational and irrational, or imaginary and real, and all those terms. But anyways, here we're going to get, the first answer is going to be negative 11 plus 19 is 8 over 12. Which would reduce by 4 down to 2/3. And the other one would be negative 30 over 12, which would reduce by 6 down to negative 5 over 4. No, 2. 6. 12 reduced by 6 is 2. Yeah. There we go. That should be good. And again, I'm going to get 2 answers. Again, in this case, we could have solved this polynomial by factoring. And in any case, when factoring is possible, if you're wondering, well, how should I factor it or not? If you see a way to factor it easily and quickly, I would use factoring instead. Like looking at the last example here, this one appears to be factorable because, well, 20 is 4 times 5, and 5 minus 4 is 1. So you can kind of do a quick magic X in your head and think about, well, would this work or not, as a totally separate approach. But of course, quadratic formula is pretty quick in the case when it's easy to factor too. So that's a totally acceptable approach, because I would have negative b plus or minus b squared minus 4ac all over 2a. And the discriminant here is just going to be 81, which comes down to 9. So, you can do these pretty quickly as well in the case when the numbers are relatively easy, like small 1 especially makes it a lot easier. And I'm going to get negative 10 over 2 is negative 5, and 8 over 2 is 4. Again, as I said, though, you could have solved those even faster just by factoring, because that one's pretty easy, but, comes down to what approach do you think is easier. And on the final, feel free to do it however you want to do it, whatever you think is fastest or easiest. But those are some of the things to look for as you're simplifying with the quadratic formula.